Hello, let us look at this proof. Prove that 3 to the 2n minus 2 to the n is divisible by 7. How do we do that? Solution. The method that I have chosen is a proof by mathematical induction. Again, for a quick reminder, mathematical induction will let our statement be called Pn. We show or demonstrate that Pn is true. Then we assume that for some integer k, pk is true. We assume that one. And then we use this to prove that that statement is true for the next integer, which is pk plus 1. The moment we show that that is true, then we can now conclude. Okay, so these are the main steps for the demonstration or proof by mathematical induction. All right, so those are the steps that we're going to follow up there. So let's start. So we let our statement be called Pn. Let our statement that we want to prove be called Pn. Right? Now let us check if P1 is true. What is P1? It simply means n gets the value 1. Now P1 will mean n gets the value 1. Now what is this? This gives us 3 squared minus 2, which is 9 minus 2, which is 7. Okay, clearly 7 is divisible by 7. Alright, so conclusion, this implies that P1 is true. Now, assume the statement is true when n is k. Therefore, we're assuming that pk is true. Right? If that is the case, then we're saying that this statement, pk, when n takes the value k, we're saying that this expression is divisible by 7. And so, how do we write that? It will be some whole number multiplied to 7. Alright? That whole number should be an integer. Okay? If this expression is divisible by 7, then this expression can be conveniently written as some integer multiplied to 7. Fine. So we assume that, and then now we have to prove that the statement is true for the next whole number after k. We have to prove that the statement is true for the next whole number after k. And that next whole number is k plus 1. What is pk plus 1? It simply means that n gets the value k plus 1 in that our expression. So pk plus 1 is 3 to the 2 into k plus 1 minus 2 into k plus 1. Okay? So what is this? We want to prove that this statement is divisible by 7. This is 3 to the 2k plus 2 minus 2 to the k plus 1. This is the same as 3 to the 2k times 3 squared minus 2 to the k multiplied to 2. Okay? Now, we are assuming this, and we need to use this information. Okay? This information, we need to use this information. How do we bring out this information from here? And how do we know that our final expression is actually divisible by 7? Those are the two main challenges that we'll have to work with at this level. So the first thing is to bring out 3 to the 2k minus 2k. All right? This is the same as 3 to the 2k multiplied to 9. 3 squared is 9. Okay? Here, 3 to the 2k minus 2k, we can see 3 to the 2k minus 2k. So it's very, very important to bring in 7. So we'll write 9 here as 7 plus 2, because here we have 2. Alright, just look at it, just watch. So we have 3 to the 2k. Now in the place of 9, we say 7 plus 2, because 9 is the same as 7 plus 2, minus 2 to the k multiplied to 2. Okay, now let's open this parenthesis. We have 3 to the 2k, all of that multiplied to 7, plus 3 to the 2k multiplied to 2, minus 2 to the k multiplied to 2. Alright, so here we have 3 to the 2k multiplied to 7, plus we have 2 common here, we can factorize out 2. 2 into 3 to the 2k minus 2 to the k. Now look at what we get here. We have 3 to the 2k multiplied to 7, and then 2 plus 2 into 3 to the 2k minus 2 to the k. But what do we have here? We have 3 to the 2k minus 2 to the k, which we assume to be divisible by 7, and we call that m multiplied to 7. So we'll just come and put here m multiplied to 7. So we have 3 to the 2k multiplied to 7 plus 2m multiplied to 7. Alright, so you can see 7 is common. So we end up with 7 into 3 to the 2k plus 2m. What can we say about this statement? What can we say about this statement? We see that clearly this statement is divisible by 7, because this long expression here is multiplied to 7. If we divide this by 7, we are going to have this expression, which from all calculations is an integer, it's a whole number. So we have demonstrated that the statement pk plus 1 is divisible by 7. All right? So we say what? Which is divisible by 7. Which is divisible by 7. Which is divisible by 7. So the last thing now is our conclusion. How do we then conclude? How do we then conclude? Conclusion. We have shown that P1 is true. We have shown that Pk is true, or we assume that Pk is true to demonstrate that Pk plus 1 is true. Now, P1 true, P for any integer, K is true. P for the next integer after K, Pk plus 1 is true. Conclusion, therefore, we expect the statement Pn to be true for all natural numbers n. Alright? Therefore, the statement 3 to the 2n minus 2 to the n is divisible by 7.